Hello and welcome to this IVT-S online video tutorial about how to configure our IVT-S current and voltage sensing module with Busmaster. This video tutorial contains 6 chapters: getting started, parts and wiring, setting up Busmaster, configuring result messages, configuring CAN IDs, configuring the CAN baud rate, and configuring overcurrent thresholds. In this chapter, we will talk about how to configure IVT-S result messages. For this, we will need the IVT-S how-to document version 1.2 and the IVT-S datasheet version 1.01. Both documents are available for download from our website isabellenhütteusa.com or from the websites of one of our partners. Now, what we want to do in this chapter is to set the second voltage channel U2 to send a result message in cyclic mode every 60 milliseconds. This procedure can be found in the IVT-S how-to document on page 3. Now for this, we will have to send 4 different command messages to the module. First, we will have to send a command stop message to set the module into stop mode. The module will respond with a response stop message. Then we will have to send the crucial config result message to the module to set the parameters defined above. The module will respond with a response config result message. After that, we will have to send a command store message, and the module will respond with a response store message. Lastly, we will send a command start message to have the module start measuring again. And the module will respond with a response start message. Now we will look at how to put together the command stop message, the first message that we will have to send. This can be followed by looking at the IVT-S datasheet page 25. And we will look at the section command set mode. Now, the command set mode basically defines whether the module is in stop mode or in run mode, and it has 2 different settings: the actual mode, which is valid until the next reset in data byte 1, and the startup operation mode, which requires a store command to save the setting, and which is valid after each startup. Now, to set the module in stop mode, we will have to choose data byte 0x34 for the set mode message, and in data byte 1 we will choose 0x00 for the actual mode stop to set the module in stop mode. Optionally, we can also set the data byte 2, which is by default configured to 01 run, as if we want to configure the startup behavior after the next startup, but this is not mandatory. Data byte 3 and 4 are for future access and don't have to be used, so we can just leave them as they are at 0. Now we want to talk about how to set the config result message to configure the second voltage channel to a cyclic measurement of 60 milliseconds. This procedure can be looked up on page 23 of the IVT-S datasheet in the section Set Config Result. Now, the first thing we want to do is to configure data byte 0, and in data byte 0 we will have to choose what channel we will actually configure. The low label here of data byte 0 represents the actual channel that we will have to reconfigure. The high nibble is gonna stay at 2. Now for that, there's a table in the data sheet on page 21 that actually lists the MUX-bit ID of the corresponding channels. Now, as you can see, for the result U2, we will have to choose 02. So that means our first data byte is going to be 0x22. The next thing we will have to do is we will have to set the low nibble of the first data byte. As we want the U2 channel in cyclic mode, we will have to choose 2 for the low nibble of data by 1. The high nibble of data by 1 is to configure the endianness and the sign of the reading. Now, the default setting here is big endian 0 and sign unchanged, which is also 0. We're going to leave the high nibble here because we don't want to make any changes at this point to the endianness or to the sign. The third step is to set data byte 2 and 3, which is the output cycle time. Now 60 milliseconds decimal in hexadecimal is 0x003c. Please be mindful that this is a big endian number, as our module is by standard configured in big endian, so it stores the most significant byte of a word at the lower memory address. The next step is to send a command store message. This can also be found on the data sheet on page 25. The section here is command store. Now this message is very simple. We just have to put data byte 0 to 0x32, which is the command store message. Nothing else to do here. The last message we will have to send is the command start message, also to be found on page 25. Again, we have to go back to the section command set mode. Again, we will have to type in our data byte 0, 0x34 for the set operation mode. This time though, we will choose data byte 1, 0x01 for run. Again, optionally, you could set the data byte 2 to either stop or run, whatever you want the module to do after startup, after reset. But if you wanted to change the data byte 2 here, you would have to send another store command after this start message. Data byte 3 and 4 will again stay at 0. So now we're back in Busmaster to actually go through how to put the messages that we just designed into the program and how to send them out to the module and actually get the module to respond to our messages. Now for this, we're going to switch back from the Tools tab to the Can tab. The windows that you will need are the message window right here, which shows you the messages that have been sent to the module and received from the module, and the transmission messages window right here. This is actually the window that we're going to use to put the messages into the system. Now the transmission window can be pulled up by simply clicking this button right here. And when I click there, you can see it's already there, so nothing happens. And the message window can be pulled up by clicking this button here. The first line here, the activate button, has to have a check mark and then you will see it. Also, just an additional hint, under the Views tab right here, you have the option to actually arrange windows by cascading them, tile vertically, tile horizontally. So I tiled them vertically, that's just the view I like best. Just a little hint if you're not happy with how the windows show up here on your screen. So now we go back to the Can tab and we will start off in the Configure Transmission Messages window right here. This window has 3 boxes: the transmitted messages frame list, the data byte view, and the signal details. Now the first thing we have to do to add a message is to double click on this field where it says Add Message. By doing so, you will see that a drop-down menu comes up with all different categories of messages, and we will always select the first one, the message command, because all the other ones that we see down here are actually messages that are sent by the module and not relevant for configuring IVT-S. And we see all these messages here because we uploaded our CAN-DBC file before into Busmaster. Now we select the first message, and by doing so, you can see that all command messages populate down here under Signal Details. So the first thing we're going to do is to put in the stop message, and you can see down here under Signal Details, there's a list of all the command messages, and you can select one of them. I'm going to select the actual mode message right here because that's the one that we're going to need for the stop message. And as you can see in the signal name, the first 2 digits here are always the data byte 0. So that can be of a little help when you put the message in the data byte view up here. Also on the right hand side, there's a matrix, and this matrix basically has the data bytes on the y-axis, like so, 0, 1, 2, 3, and so on, and the actual bits of each data byte on the x-axis right here from 0 to 7. So basically, the data byte 1 bit 0 is highlighted, so that means that this message will actually only accept the data byte 1, the first bit, to be changed. And you can technically also type this in as the raw value right here. So as we're gonna have the module in stop mode, the value that we actually need here is 0, but if you would type a 5 in here, for instance, it would switch to 1 because 1 is the only allowed value in there. So, and it will also populate up here the data byte view under the data byte 0141, but that would be the run mode now. So this helps a little bit with regards to the accepted bit values that actually can be entered in this window. So I'm going to switch it back to 0 because we actually want the data byte 1 to be 0. And then for the data byte 0, we have to type in 34 for the stop message. So we're going to hit OK. And this is all we need to do for our stop message. Now in the frame list up here, you can see there's a couple of parameters. There's the message name, frame ID, channel, data length, message type, RTR, which is the remote bit, which we won't need, repetition in milliseconds. This is if you want the program to actually repeatedly send this message with a certain frequency of, for instance, 10 milliseconds. But we don't want that. We only want the message to be sent once. Now, there's different ways of sending the message. You can either click the Send Message button, which should highlight like so, or you can use a key from your keyboard. So you can set the check mark here, and now if I would hit the A key on my keyboard, this message would be sent. And we're going to use this procedure for this demonstration video. So the next message we want to put in is our configuration message. And as you can see up here, I already added another command message to our frame list. And I actually brought up the appropriate message for defining the U2 cycle time from the dropdown. As I mentioned, you don't have to necessarily do that, but it sometimes can be a little bit of a help. So we're going to proceed and put in data byte 0 with 22. Data byte 1 will be 02 for cyclic mode. And then data byte 2 and 3 And I don't know if you saw that, but this is actually also highlighted here in the matrix, that those are the crucial 2 data bytes that need to be used to put in the cycle time, have to be the 60 milliseconds converted to hexadecimal. And we did that before already, and we know that 60 milliseconds in hexadecimal is 003C over 2 data bytes, and as we are in big endian mode here, we will have to leave data byte 02 blank, and we will put in 3C into data byte 3. And that's it as far as the configuration of the config result message goes. We will again put the check mark for the keyboard assignment, and we will assign the letter B to send this message. The next message we're going to put in is our store message, and again we will have to add a command message, what I already did up here. And for the store message, there's nothing else to do but to enter the data byte 0, which is 32. Entering it right here. And now we still have to assign a letter, and we're going to choose the letter C for that. The last message to enter is the run message. For that, I again entered a new command message, and we're going to again use the actual mode message here. So we're going to enter data byte 034. And for the data byte 1, we're now going to enter a 01 because we want the module to start running after our configuration. For the key, we're going to choose the letter D to get this started. And now we can go ahead and actually start sending those messages to the module. Sending the messages is pretty easy, so the only thing we need to do as we assigned those keys is to press the keys. So I'm going to press the key A now. And as you can see, we sent the stop message. Module confirmed the actual stop message right here. And as the module was in stop mode already, nothing else happened. But now we're going to send the configuration message by hitting the letter B. And you see that the module sends the corresponding response message. So, you know, the command has been received by the module. We're now going to press the letter C to send the store command. And also this is confirmed by the module. The module for store confirm message will always put the serial number of the module on data byte 5 and 6 right here. This is just a normal procedure. And now we will hit the D key, which is actually the start message. And as you can see, now the module has started sensing with the U2 channel, the U2 voltage channel, and it does that with a 60 millisecond cycle time. And you can see the messages coming in here in our message window. Last thing we want to do is to look at the actual structure of a result message. For that, I have sent another stop command to the module, and you see now the display froze to one result U2 message here on the screen, and we will now go ahead and analyze this message to see what content we have here. For this, we will go to the IVT-S datasheet, page 21, section 8.1 result messages. Now, if we look at the spreadsheet right here, we see that the data byte 0 is always multiplexed and it represents the channel number. Now, as we're looking at the U2 result messages, we have to go in the other spreadsheet down here, and we see that data byte 0 has to be 02, and we can find that in the result message that we received from the module. Data byte 1 is divided here into the low nibble and the high nibble. And the low nibble is a cyclic counter for each channel. It just counts from 0 to F hexadecimal. And if we look at the low nibble in our result message, it's a 9. So this is just where the counter stands for this message. The high nibble is activated if there's any kind of error or an overcurrent signal. So as you can see, the 4 bits, bit 0 is set if there's an overcurrent signal, bit 1 is set if the result is out of spec or out of range, bit 2 is set if any result message has a measurement error, and bit 3 is set if there's a system error. And as our high nibble bit of the data byte 1 is 0, we know there's no error. Data bytes 2 through 5 are the result itself. And if we convert data byte 2 through 5 from hexadecimal into decimal, we see that the actual result is 12,012 millivolts. Please consider here that the standard IVT-S configuration is in big endian, so that means the most significant byte of a word is stored at the lower memory address. Please check out these additional videos linked below for instructions in performing various configurations with our IVT-S modules.